Alright, in this video we're going to talk about adding cutter compensation to our toolpaths. So far we've learned how to write a toolpath, offset half the distance around our profile, and basically what we've done a tangent move in line with our first piece of geometry and then a tangent exit when we come off of the part. So we're going to replace that tangent entry and that tangent exit with a perpendicular move, and during that perpendicular move, as we approach our toolpath, we're going to activate cutter comp, and also on the last move we're going to add a perpendicular move to cancel cutter comp. Alright, so let me show you the toolpath, what that's going to look like. It is only going to affect the finish pass, where we're going to have to add this extra move, and then I'll show you what code to add on that line to actually activate the cutter compensation so that we can make minor offsets to change the dimensions of our part. Alright, so now let's take a look at the toolpath with a perpendicular move to activate cutter comp, and all it's going to do is basically make 100,000 perpendicular move right there, and on that line of code, when we post that out or when we write that, we're going to add a line left cutter compensation code. In this case it will be a G41, and that allows us to make minor changes to the dimensions of the part by adding an offset in the tool offset page, okay, and the G41 together with a D value, the D value that matches the tool number, and I'll show you all this in the program, but this is the only move that has to be added to the code in the beginning, and then as we go around the part, the very last move, once we've come off the part, we're going to make a perpendicular move away from the part where we cancel cutter comp with a G40 code on that line. So let's post this code out and take a look and see how we add cutter comp to this toolpath. Alright, so here's the program with cutter comp included. Let's go ahead and step through it. This is program number 1. We're going to be using tool number 1, which is a 1/2 inch flat end mill. Here's our safety line, and make sure that we put that G90 on there, just like covered in the previous video. Just a brief description of what the toolpath is. We'll make a tool change, picking up tool number 1. And again on this line we have a G90, G54, and we are approaching the lead-in position of our toolpath. And notice the Y value is at 2 inches 350. So then we come down, we go to a depth of Z minus 0.5, and then the next line is our G41. Now remember, G1 is already active, it's modal, so no need to enter it again on that line. What I do want you to remember is a G41 can only be called on a G1 line. You cannot activate a G41 offset in a radius, so not on a G2 or a G3 line. Okay, so it has to be on a G1 move. So that's why I always say make that perpendicular move 100,000, because that's easy math, and on that line you activate that code, you activate that cutter comp. So G41 activates line left. I'm going to show you a little bit later what line left really means, but G41 is what you're going to use anytime you're climb cutting around a part. Okay, the D1, what it does, it looks at the tool page on line 1 where the tool data is stored, and it's going to look at the offset column, the where offset column, and it's going to bring in any value that is entered there. So if we have a minus 1000s, that means it's telling the control the tool is not exactly 500, it is now 499. And so what happens is it takes a 1/2 thousandths per side more. So on the overall dimension, if you checked it from left to right, the dimension instead of 4 inches will now be 3 inches 999. Okay, so that's what cutter comp does. If it's a -5 in that column and brings that in, when it sees that D1, then it thinks that the end mill is 495 thousandths. So it takes 2.5 thousandths per side off for an overall dimension of -5 on that 4-inch dimension. Okay, I hope that makes sense. So let's complete that move. Let's step through it. You can see it made that little perpendicular move right there. It activated cutter comp on that line. And then as we go around, we'll go ahead and go to the G40 line right here on line 31. You can see it moved away from our exit. So at this point we're beyond the part. And on that line, again, it's a G1 that is active. If it was a G2 or a G3, make sure that the G40 is on a linear move. Okay, so G40 X -1 inch 350 cancels cutter compensation that was activated here on line 13. So that is how you add cutter compensation to your finish pass. Let's take a look at the tool data page and where you would enter the value that the D1 on line 13 brings in when it's reading a G41 command. Alright, so here you're looking at your tool data page. You can see your geometry. That is the number that you entered when you set the tool on top of your tool setter. You can have a where column for the length. So any value you put in, the where column will add to the length, add or subtract of that length. Then what you're looking for the cutter comp is the diameter offset. Okay, so there's a geometry and a where column, and the geometry is usually used if the tool has been reground. So let's say the 1/2 inch tool was reground and it's now 490, so you would automatically put in -10 thousandths in the geometry, because the machine will have to compensate for the diameter that is not there. So only on the finish pass, when it's reading a G41 with a D1 for tool 1, will it read in that geometry offset. Now normally we put our offset in the where offset column, just like you see in here. You're seeing a -8 tenths, a 2 thousandths, a -5 thousandths, and a -1 thousandths. So if I wanted to take away material off of that 4-inch on tool number 1, let's say I wanted to reduce the overall dimension in both directions from 4 inches to 3 inches 995, I would actually add -0.005. Okay, if I wanted to leave it big, sometimes your tolerance on your print will say 4 inches plus 10 minus nothing, then I purposely want to add 5 thousandths or even closer to 10 just to be on the high side, and then the machine will think that the tool is big and actually stay away from the geometry, leaving the part larger. So I hope that makes sense. Look for this page in your machine. You may have to switch to 2 different screens to be able to see the geometry and the where offset page, but it's going to look similar to this. Alright, so far we've learned that when we create a tool path for the outside of a part, we're always going to pick it in a clockwise direction, and therefore the tool will always be climbing, and that's what the machine likes, climb cutting. When we add cutter compensation for a outside contour, we're going to be adding line left cutter compensation, and that's done with a G41. Okay, so what happens, the best way I can explain this is as you're looking at the tool from behind, okay, it is on the left side of the part as it's going around the profile. So that is the best way I can explain it. It's almost like driving around the block. You are on the left side of the sidewalk. That's about the only illustration I can maybe put in your head. It's just like, at least in the United States, line left is as if you were driving around the block where you're on the left side of the sidewalk. Now let's take a look at a line right. So a G42 would be considered line right, and we would still have that perpendicular move to activate cutter comp. And as you can see, we're going around the part in the counterclockwise direction. And if I'm looking at the tool as it's going away from me, I am on the right side of the part. So we're actually going against traffic here as we're going around the block. So that is considered conventional cutting. It will be rare when you ever write a G42 routine, but that's what line right looks like. I hope that makes sense, and I hope that visual helped you. A G41 being line left, the tool on the left side of the part as it's going around the part.